Ladies and gentlemen, good afternoon. Thank you for joining. So this is the first year we're having a telecom track, a train event. And it's awesome to see so many of you interested in the topic. My name is Donatello Gassi. I'm an AWS senior manager of the Solution Architecture Group. A little bit more than 1 year and a half ago, I started working supporting Vodafone worldwide in their adoption of the AWS cloud services. When I first met the Vodafone TV team, I was actually asked 3 questions. And I believe that if you work into the telecom space, you will get the same questions. So the first one was around agility. Can we implement the platform and the solution in the AWS quickly? The second one was around cost. Are there cost savings of the migration and the implementation on the AWS clouds? And the third one was around innovation. Can Vodafone TV deliver a better customer experience to their customers using the AWS services? So here we are, and in this session, you will hear from Vodafone the answer to these 3 questions. So what to expect from the session? The first one, you will be understanding how Vodafone has implemented a cloud-centric TV platform. So this is the question of agility. Second, you will have a deep dive on 2 AWS solutions that help in the field of operations automation. And here you might think about both effectiveness, agility, and also cost control. The third one, you will hear about the future of Vodafone Television. So without further ado, let me introduce Wolfgang Zeller, who is Vodafone Consumer Product and Services Head of Video, who will tell you about the journey so far.
So good afternoon too. I said my name is Wolfgang. I'm working in Vodafone Group in technology. We're looking after consumer product and services in regards of video. So my team and I, we look about everything Vodafone is doing in video. That basically means we start with Iceland, we go through Europe, Africa, down to India, New Zealand, and then we go to bed in theory. In practice it never works because we're up 24/7. Just fairly quick about Vodafone, for those who don't know, Vodafone is one of the largest telco operators in the world. We have 26 countries where we operate mobile services. Out of the 26, we have 19, which is important for this discussion. In this topic, we operate a fixed line business, fixed line services for our customers. We have 49 partner markets where Vodafone is partnering up with local operators in the market to provide jointly services. Customer numbers very quickly. By end of June of this year, we had roughly 523 million mobile subscribers, and out of that important number, 18.5 million fixed broadband subscribers. Of course, we run our own backbone. We have acquired cable and wireless a time ago, not Cablevision, sorry. And we are connected, of course, 100 different countries and have our own infrastructure for that. So for the discussion today, let's do a little bit of a history on TV. TV is always a very interesting topic. This one has a little bit of more European focus. So in the old days, it was like a classic lean-back broadcast experience, 1.5 TV screens on average in a German household. In the US, definitely more. But it was always a broadcast experience, one-way broadcasting, a TV show, one after the other. In the back end, you had, of course, this is a picture taken out of an operations center. It shows people monitoring the service, literally each and every channel, looking after it, and the whole system was built for high service availability. So it was 100% uptime, a downtime did not exist, a failover did not exist. It was just designed from the ground up to be 100% resilient against anything of this. However, over the years, you build a huge infrastructure. You build obviously a network to run the service, that's fine. But you connect to content providers, you need to pick up contents, you need to worry about satellite dishes and whatnot, encoding and so on and so forth. And it was all focused around linear. The data centers that we have for this are dedicated data centers. It's not an IT data center, it's really a broadcasting data center. It looks completely different in the early days. So there was nothing like IP, but tons of cables, screen cables. You were actually really wiring the service together and connecting components. For those of you who know those green cables, SDI is still around there. You just can hardly beat them to that. If something was talking IP, it was a bit of alien. It was for some management stuff for the young guys, yeah? But for the classic broadcast operator, it was really hardcore broadcast engineering. Yeah? Doing that change is something obviously you hate to do. So introducing anything new, any new service took a while, and we had very strict testing procedures and a waterfall process, which was not really even a waterfall, it was super slow. Yeah? If you look today on the Vodafone TV footprint, yeah, this is like a slide that has like 3 years of history in Vodafone. Yeah? It started roughly 2013. You can talk a lot about it. If you name any access network technology, yeah, you will find it somewhere in Vodafone. Yeah? We have cable networks, we have pure fiber networks, we have DSL networks, of course, obviously mobile networks, or a combination of those. We even had satellite services. Yeah? Different countries, different grade of maturity in terms of TV service. All in all, if you sum it up, we have roughly 10 million TV subscribers as of today. But as you can see, each and every country, different content lineup, each and every country, different platforms, each and every country, different regulations, and each and every country, different maturity in the market and a different proposition towards our customers. Yeah? So the idea was 3 years ago, we need to do something about this. That's why the video team came into existence. We need to consolidate our platforms. We need to make sure we have consistent experience for our subscribers across different countries. Yeah? If you take, for instance, mature markets like Germany or Spain, decent pay TV cable operations. If you take new markets, let's say India, a mobile footprint, yeah? But still, a lot of mobile customers out in this country, total different service. Yeah? So what did we do? What do you need to serve if you want to have a serious pay TV operation? Of course, you need to give the customers what they already know, which is traditional linear TV watching, some sort of set-top box services depending on the markets, simple things. It's a local PVR, you can do recording, pause and rewind. I'm not telling you something new. And eventually, depending if it's available in the market, some video on demand services. Yeah? But that's not the end of the story. Customer demand is clearly they want to watch TV anywhere, on any device, yeah? Be it now a PC, a tablet, a smartphone, a smart TV, a dongle, whatnot. Pick, choose. Customer want to watch anytime. You want to go everywhere, watch your recordings. If you miss the show, you want to do a catch-up services. Or if you miss the start of a show, you just want to go back and start over again. Yeah? All doable. But then all of a sudden, third-party applications, third-party content, super important. Yeah? Apps, widgets. And on top of it, TV needs to become social, needs to become interactive more, needs to have personalization and recommendations, a whole lot of things to do. We took that back, we took them on board 3 years ago, and I have to say the product guys in our department did really a good job. And that's the answer, it's Vodafone TV. It now exists in release 2.5, it's launched in 3 markets, it's available in Spain, Italy, and in New Zealand recently. 2 of them run completely out of the cloud. The third one is going to migrate into the cloud. And it's all what it is. It is a multi-device, multi-access, network-capable platform. It runs out of one platform. It is accessible on your PC. Big TV screen experience, still on a set-top box or a dongle. Runs on any mobile device, iOS or Android, no matter what. Yeah? And it has everywhere, each and every country where we roll out the service, the same look and feel. Different language, of course. Different regulatory requirements, but that's the service that we have. That's what the user receives from us. Technically, we have 4 core pillars that are super important for us. First and foremost, it's one product. One product means it's one platform. This platform needs to support different business models. If you have one product and one platform, as a consequence, you have only one backend. Yeah? You have only one infrastructure that is deployed centrally, that should simplify operations. If you do that, if you run in the cloud, then you have one operating process that's equal for each and everybody. There is no difference if the service is deployed in Germany or in Italy or in Spain, it's all the same. Processes are all the same. And you utilize, of course, the agility, optimization, and everything you get out of the cloud. The last one is very typical for telcos and mobile operator, which is called multi-opco team. Behind that is what we are very strong is in industrialization of products. That means design, build once, and then deploy multiple times. Without the same team, centrally managed, should give you a faster time to market and rollout. Those were the core pillars. Believe it or not, when we started 3 years ago, we did our first what we call 404. It's a classic HTTP error code, and it just didn't really work out. What did we do? Since we were not so confident on cloud, and I haven't met Donatello at the time, we go back on premises again. We ask our vendors that we picked by choice, that came out of the cloud, that used web technologies to go on premise again. Because we said, hey, no matter what, we can build infrastructure, we give you the hardware, we give you the network, we run it for you. That was super expensive and painful. And by doing so, we increased our operations cost, and our maintenance cost just went out of the roof. Because, keep in mind, we were like the classic TV guys, not really the web guys or the cloud guys. So we looked around and said, okay, that didn't really work out so well. What are others doing? If you look at the Amazon, the Netflix, the Googles, and the YouTubes of the world, they don't have this process overhead like we have in those large organizations. They can use agile methods, DevOps methods, which for us was just really an alien concept at the time. Failure is also part of the culture and doing stuff. Not with us. Broadcast has to work all and any time. Any changes are enemy. We test like forever, and then we deploy one version per year, not on a weekly basis. Mission impossible. Or the concept of doing A and B testing, playing around with our customers. That was not in our DNA. But we said, okay, fine. Take a step back. Think about it. What do we want to do about it? So we pushed really everybody, and we pushed ourselves to do a big shift in paradigm, how you do TV. We said, okay, let's try a lift and shift and push as much as we can into the cloud. Whatever it is, just push it. Go to the limit. We trialed it first with a small lab environment running in the cloud. It was fantastic. People got super excited about it. It wasn't really cloud, it was more infrastructure as a service, but for us it was a major improvement. No commissioning of hardware, no lead times, no wiring. So all the stuff you don't need to do, you can possibly do it with a mouse click. The time you gain and the resources you gain, you invest in more software development and new features instead of caring about hardware. And finally, where we ended up all of this is the picture on the right, which I leave to Michael and the others to explain more in detail. But what we did, we moved all our environments into the Amazon cloud. It's an integration environment, it's our testing environment, production environments. The biggest problem in this whole thing was security. PayTV is all about security. Secure content, watermark content, make sure that content goes where it belongs to and where it doesn't go where it should not go. But we also manage this. And by doing all this, we're really able to cut down our CapEx spend dramatically, in certain cases down to 75%. On top of it, we could triple our development speed and our release cycles. So we do backend now quarterly. We do clients or 3 weeks basis. Before that, it was just like really sci-fi for us. And on top of it, we improved quality and turnaround time significantly and increased the value for our subscribers. So with that, I would hand it then over to Donatello to take us further. Thank you.
So thank you very much. So as you have seen, can you hear me? Okay, good. So as you have seen, so the story of Vodafone so far, the journey, it's something that you would be classifying as lift and shift with a bit of a twist. So there is a little bit of re-platforming, there is a little bit of re-architecting. But so this has been answering the first question, which is how do we achieve higher agility? And this is one of the key benefits of the clouds. It's on demand, it's available, you have services, it works, and of course you can be faster. So now let's answer 2 other important questions, which are questions related to operational effectiveness and cost control. So how to automate operations in the AWS environment once it's there, even in the lift and shift paradigm, and how to manage the schedule of multiple test environments. So I'd like to introduce 2 solutions. One solution is called the Ops Automator, and the second solution is called the Instant Scheduler. This solution will go a little bit deeper, so we'll give an architectural overview of what they are, and also we'll do a demo so that you see them in action and the benefits you can achieve. So what is it, the Ops Automator? The Ops Automator is a solution that enables customers to optimize their operations of their AWS environments by automatically executing actions on their resources at specific moments or events. It is a framework. So this means that it comes with a big, it's a solution coming with a CloudFormation template. You typically deploy this in your operations accounts. And the good thing is that it can manage resources in the multiple accounts you have using cross-account roles. And this is a good thing for enterprises, because enterprises like Vodafone, you will have multiple accounts for multiple reasons, actually living in multiple regions, because another benefit of the clouds is the ability to go global in minutes. So what are the benefits of this framework, the Ops Automator? So first of all, it's handling scheduling, resource selection, filtering, aggregation, error handling, configuration, logging, auditing, but more importantly, concurrency. So in the moment you start executing multiple actions on the AWS APIs, you might be throttled. So the framework is able to handle the throttling and handle the repetition. And more importantly is working across multiple accounts. Yeah? So this is very important for very complicated and very complex architectures. It is extensible, so you can code your own actions. And what we have been experiencing in our private betas is that the operationalization of regular tasks goes from weeks to days to hours. So let's have a look at the generic architecture of the Ops Automator. So a few concepts, and then we'll go the dive deep. So first of all, in order to start tasks, you can have either events or moments. So specific things happening in the architecture or in specific point in time. So after the task is triggered, there is a selection of resources on which there will be actions executed. And every action that is executed is getting tracked so that you have full visibility of what is happening or in the overall operations automation framework. So as per today, there are multiple categories, and we have 24 actions. We have actions for EBS snapshot management, for AMI management, creation, delete, and sharing, for instance management, start, stop, terminate, and tagging, for SSN run commands, for RDS snapshot management, RDS instant management, Redshift snapshots, CloudFormation, stack management, and DynamoDB. Again, this is getting extended. So with this in mind, let me pass it to Ari, who is the lead developer in charge of Ops Automator, for a short deep dive on the architecture and the demo.
Thank you, Donatello. My name is Ari Levenstein, lead developer of Ops Automator. Let's first do a deep dive on the architecture of Ops Automator. You saw the list that Donatello told you, like we do handle things like logging, concurrency, how do you handle throttling, error logging, audit trails, things like that. Everything is in the framework. It allows you to focus, to build your actions. Let's go from left to right. You remember Donatello's diagram. On the left were the events. What we have on the left side is handlers for moments in time. And again, I'm going to show you in detail how we configure these things. Like at this moment in time, I want this to happen. Or another thing we added is like when something happens like, hey, an instance is started or stopped. I want this task to start. A snapshot is created or shared with me. I want to start that task. So rather than polling, using a lot of resources, we have tasks which we can actually trigger by events. We also will have S3 events. So when an object is created, for example, you update an S3 template, you can start an action called update my CloudFormation template. So on the left side, there's the event handling and the starting things. And as Donatello said, it's a multi-account, multi-region solution. So we're already handling the case where you have multiple accounts in multiple regions. We actually forward the events from the other accounts, different regions, into the account where the solution is actually deployed. In the middle, you see two tables. One of is the configuration table, where we store all the information, configuration of the tasks. And the other one is the task tracking table. The approach we took, like every step you're going to take in this framework, every action, every step in the action, you're going to perform on your resource, we're going to track it. Actually what we do, we create a task in the table, and we update these entries. And every step is the result of updating the table. So we update the table, and that triggers the next step in the process. And of course, on top of that, you got CloudWard logs. So we have a complete audit trail. Any exception that happens, what resource are we doing what on, is kept in that table and in the log files. So you got full auditability on your, on your actions. Okay, and moving to the right, you see there's a lot of microservices, a lot of Lambda functions handling things like concurrency. For example, I don't know if you ever tried to implement a script for copying snapshots. You can only do 5 from an account to a specific destination. What if I copy 6 or 7 or 100 snapshots at a time? We take care of it. Just by declaration in your action, you can say, I only want to have X of this action. We have completion handlers. You start an action like creating a snapshot. We check the result of that action. We constantly keep checking like, hey, that snapshot you wanted to create, is it already there? You can specify timeouts. So there's a lot of microservice in the solution. It's completely serverless, that's to handle the functionality of the framework. Well, to be honest, it's not completely serverless. Sometimes you have to run actions. And again, have the customer say, hey, can I manage 30,000 snapshots with your solution? It's all Lambda-based. Lambda has a limit of 5 minutes. So what we did, you can have an option to configure an ECS cluster, give the stack the name of that cluster, and if you have an action or a step in an action, you say, hey, this will take probably longer than 5 minutes. What you can do, you configure it, say, use ECS. What we'll do when we execute that step, we start a task, and the task is actually grabbing the code from your Lambda function, creating the context, and running the action, and you have more than 5 minutes. Okay, there's a stack of tasks you see there on the lower right, and that's a kind of library with functions. We want to ship with at least 24 actions when we ship this version 2. Well, what's an action? An action is a bit of Python code. You implement a pattern, you specify metadata about the resources you want to act on, timeouts, which parameters you have. It's a lot of declaration. And then there's one core method called execute. And when you remember Donatello's slide about selecting resources and taking action on them, that's all defined in the metadata. So when you start coding these things, you say, I'm interested, this service, these resources, I want to do that kind of aggregation. It's all with declaration. Another thing you specify is, what permissions do I need to execute this? Like you want to create snapshots, you need permissions to do that API call. So what we do when you deploy this into your environment, we generate CloudFormation templates on the fly. So we have actions, and we create CloudFormation templates to configure tasks based on these actions. And that's what you see in the middle. So we take the meta information from these classes, and we generate the UI also for actions you develop yourself. And everything, like you said, you see the cross-account roles. We give access to other accounts by using creating cross-account roles. And again, based on the information from the metadata information from the action implementations, we generate these things for you automatically. So let's do a demo. Well, actually a demo. What I did, because of time constraints, I did a demo a couple of days ago. I recorded it, and I took some highlights. What I'm doing here is I'm going to set up a DR scenario. Again, we got a long list of things the framework can do. We choose to do a kind of standard DR scenario. I'm in an environment. I have EC2 instances. I'm going to tag them. What we're going to do, every hour, I'm going to take an automatic snapshot of them. The next step 2, I'm going to copy the snapshots to another region, from EU West to EU Central 1. Step 3, I'm going to delete snapshots. I want to clean them up. When I have more than 4 snapshots for a volume, I'm going to delete them. And step 4 is I'm going to make this work across multiple accounts. That's what we're going to do in the demo. On average, setting this up will take me 15 to 20 minutes, including creating all the instances of the templates. So let's start by doing the first step. Yeah, it's running. Okay, so we start with the empty environment. We are in account 1, EOS 1, and we have Ops Automator installed. Ops Automator is a CloudFormation template. You install it just by going to your CloudFormation environment and running the template, and it creates all the resources for you. It takes about 10-15 minutes. So let's have a look at the CloudFormation template. I got a pre-installed version here. The name of my stack is Ops Automator 2. It's version 2 of the framework. You can give it any name. And the first thing, one of the most important parameters, is the task scheduler tag name. This is the tag you're going to put on your resources on which you want to act on. So you put a tag on it called Ops Automated Task List. Again, this is configurable. Pick any name that works for you. And the values of this tag are the actions you want to perform on that action. And again, you see it working in more detail later. You can use CloudFormation metrics, and you see the ECS cluster name parameter. If you say I probably got actions that take more than 5 minutes, specify the name of an existing cluster, and you can have an extra option in your configuration for your task saying, hey, use ECS because it probably take more than 5 minutes to complete this one. Okay, part of the installation is an S3 bucket. And again, this is generated on the fly during the installation. You have different folders. So you use specific names, so you can have multiple instances of the stack in one account. One of the folders is configuration. And what you see here is the full list of actions that ship with the framework. See, this is a video from last week. It's 22 of them. Again, we're going to ship it, I think, 25 actions. And it's not just about handling snapshot. It's also about actions on RDS, CloudFormation. We can issue run commands, from the SSM service. And again, this list will grow based on customer feedback, and you can even build your own ones. Okay, let's configure the first step, task number 1. So you see we're going to, from all the 20 plus actions, we're going to use 3 of them. One is the copy or create snapshot action. We're using the template and we create a stack. And a stack is basically a configuration saying, I want to execute this action with these parameters. The name of the stack is the name of your action. Give it an optional description, and we're going to give the time interval. Again, full cron, meaning 0, asterisk, asterisk, asterisk. Wildcard is like once every hour on the hour. Again, full cron support, with all the hashes and the slashes and thanks. We're going to run in EOS 1 in this account as well, so you can operate on the resources in this account. Time zones, 580 of them. Okay, you can trigger tasks based on time, but also on events. And again, for this task, we enabled instant started, and you can also use instant stopped. So when an instant starts or stops, you can automatically run this task. Okay, what do you want to copy? You want to copy the root volume? Yes. You want to copy the data volumes? Yes. Which account you want to share this snapshots with, which you create? And you can set the name of the snapshots. So let's go for yes. You can specify a prefix, and then you can specify a templated name. So in the name of the snapshot you create, you can use things like, okay, what was the original instance ID? What was the volume ID? What was the date? What was the time? What was the name of the stack? And also, you can do the same for the description of the snapshot. And later when you can see the scheduler or the automator in action, you can see these things actually appearing in your description. Okay, what tags you want to copy from your instance, from your EC2 instance? Which tags you want to copy from your volumes? Well, let's go for asterisk, which means all of them. Besides that, and this is a very important setting, snapshot tags. So it means like, except for all the tags you're copying from your instance, from the volume, what are the tags you want to put on the snapshots you're creating? And remember the tag we specified? Tag Ops Automated Tag List. I'm going to put that on all the snapshots I create, and I'm going to specify 2 more actions. And these are the names of the other 2 actions. Copy snapshot and delete snapshot. So I tag them with 2 more actions, which we're going to configure in the next steps. Another thing we can do, instant tags. When we create a snapshot, I can also tag the EC2 instance from which I've taken the snapshots. Okay, we set up task number 1. Now we're going for number 2. Copying the snapshot to region EU Central 1. I create them in EU West, and I'm going to copy them. We go into the folder, we take the template for copying the snapshot, and we create a stack out of it. The name of the stack will be copy snapshot. That's the name of the task we just specified, also in the tag of the other task. Copy snapshot, optional description. And what I'm going to do here, I'm going to skip the interval. I'm not going to say I'm going to check every minute if I need something to copy. What I do here is snapshot created yes, meaning every time a snapshot is created, I'm going to automatically run this task on that snapshot, copying it. I can do the same when somebody shares. So shares a snapshot with me. And this allows cross-account snapshots. So I can have another task for the other account saying, okay, when somebody shares a snapshot with me, copy it into my account. So we're allowing copy account snapshots. Okay, I want to copy it to EU Central, from EU West to EU Central. You can filter on which ones are copied, owned by me, shared to me. Which tags do you want to copy from the source volume? And again, what we're going to do here, Ops automated task list, delete snapshots. So we're copying them into another region, but at the end of the day, you want to delete them by the third task we're going to configure later. We can put a description on the copied snapshot and also on the source snapshot. Okay, and that brings us to step number 3, deleting the snapshot. A third task, template is delete snapshot. The name of the task, delete snapshot. This is the one we also use for the tag value. And we're going to run this every hour, 15 minutes past the hour. And I'm going to specify 2 regions because originally I created the snapshot in EU West 1 and I'm copying them to EU Central 1. So I wanted to clean them up in both regions. You can clean up snapshots by retention days, so I want to keep them for a number of days, or by a retention count. And retention count means I'm going to use 4 here, so I'm going to delete all but the last 4 snapshots. So you can delete them based on how many snapshots you got per volume. Okay, now what I have to do to create the snapshots, to trigger this whole sequence, is I have to put a tag on the EC2 instance from which I want to make backups. So I'm going to put a tag, same tag, Ops automated task list, on the EC2 instance from which I want to make snapshots. Create snapshot is the name of the action, the first one we did. And we put this one on the EC2 instance. And you see, when you switch to the snapshot console in EC2, you can see a snapshot is created. And Ops automated task list, the tags I put in the list, copy snapshot and delete snapshot. These tags are on it. Okay, this one is finishing. And what you see when this one is finished, it finishes. Now it's switching to EU Central 1, and automatically task number 2 is started. Snapshot is created, and I'm copying them over to the other region. See, the tags are on there, which are specified, and also here's an additional action, delete snapshot, so they get deleted by the third action. So we implemented 1, 2, and 3. Okay, how are we going to make this operate in multiple accounts? Again, that's an essential thing in enterprise accounts. What you need to do is go to the configuration folder, and there's a bucket, and there's a folder called roles. You go for the name of the action. It's template there. You download the template. So first we're going to do the create snapshot action. You download it. Then you're going to switch to the other account in which you want to run this action. Account number 2. You specify the name of the template. You create it. You create a stack. You can give it any name. And what it actually will create is a cross-account role. And in the cross-account role, you say, I'm giving permission to the role that runs the Ops Automator to perform the actions which I need to do to execute this task. So what will be created is a cross-account role. You see in the output value, there's the cross-account role ARN. What you do, you take that ARN, put it on your clipboard, switch back to account number 1, you go to the task, you paste in the cross-account role, and that's all it takes to enable it in the second account. So what you just saw in, well, normally it takes about 10-15 minutes. You set up a complete end-to-end DR scenario, creating snapshots, copying them to another region, cleaning them up, and enabling them in multiple accounts. Thank you.
So thank you, Ari. So as you can imagine, So a disaster recovery scenario is something typical. So typical in operations on every enterprise. So this is a simple way of automating such kind of activities. So let me go very quickly, and potentially we'll be shorten this a little, on different concepts that comes quite often when you want to control your own cost, which is instance scheduling. So this is a solution which enables customers to stop automatically and start their EC2 and RDS instances. So this is an easy solution that works over multiple accounts and helps you saving costs. The key scenario that you can think here is, for example, having multiple test accounts. So if multiple test accounts, and you want to make sure that they are not running during the night, so therefore you will have schedules, and during the night you will be shutting them down. But very interesting, this works both on EC2 and RDS. So there are multiple ways you can configure the schedules. For example, you can define when it starts, when it stops. Users can still stop instances prior to the schedule stop, or they can start previous to the schedule starts, or you can have even all scenarios, meaning scenarios where the scheduler will just be stopping or will just be starting. So what I would ask Ari to do is just a quick demo. So that we can then move forward into the next steps of the Vodafone future. So maybe skipping the architecture is going to be directly shown into the demo.
Yep. Okay. Okay. The solution is based on the same principle. You just tag your instances on which you want to operate. Yep. Okay. Thank you. Okay. What's the scenario we're going to implement? Instance scheduler deployed as a stack into one account. And what we're going to do is we're going to schedule instances in two regions, EC2 and RDS instances. So again, CloudFormation stack. I run my video. Okay. The name of the tag is called schedule. That's the tag we're going to use to mark EC2 and RDS instance to run in a specific schema. You specify what services we support RDS and EC2, time zone, and the regions. And yeah, we're going to operate in this account. The granularity of the scheduler, 5 minutes. And another thing you can do is collect metrics, so you can see exactly how many instances are running in what schedule. And other things you can do is specify tags. So if you start or stop an instance, you can put a tag on these instances. For example, this is stopped by the EC2 scheduler. Otherwise, your management system, hey, why is the instance down? So you can mark your start and stop instances. The schedules that specify when these instances are running are configured in a database, a DynamoDB database. And let's have a look in this table. So you define periods, running periods, and let's look at a simple one. It's called office hours. It runs from 9 till 5 on weekdays. It's very simple. This is the way you set these things up. You give it a unique name, you tell it when it runs. Again, full cron. So it also allows you things like this, in a couple of entries. Run every first Monday of each quarter. And what we do there, January, and then every third month on the first Monday of the month. So you can really use anything that's in cron to schedule your instances. In order to apply these periods to an instance, you have to create a schedule. And what's the schedule? Basically, it's one or more periods. What you see here, it's using the office hours, which you just saw. I'm specifying a time zone. And I can put UK office hours now as a value of a tag to schedule my instances. Seattle office hours, using the same office hours period, just in a different time zone. So we're sharing these periods. So if you ever change your office hours across the globe, the only thing you have to do is change that entry. And you can even do more complex things. It's very powerful. What you can do is use more than one periods in a schedule. And I have an example here. We use two built-in periods, weekdays and working days. And I'm specifying an optional instance type, an EC2 instance type. When I mark instances with this schedule, it will run T2 nano instance type on weekends and T2 micro on working days. Automatically, it will start and stop your instances, resize them, and start them back up. Okay, how are we going to apply these to your instances? You go into the EC2 console. There's a tag called schedule, the one I specified in the template. And I'm going to put a schedule name on it. It's a predefined one that's built in. It's called stopped. And we use the override status here. It's meaning stop this instance while this tag is on there. And I'm also having a stopped instance. And I'm going to put the running schedule on that one. And this is also a built-in one. Override status is running, meaning keep this thing running while this tag is on it. And again, you can use the UK office hours, Seattle office hours as well. Same thing applies for RDS instances. I can use the same schema names. We don't support resizing here. It will ignore the settings, but you can still use the same names. I create a tag called schedule, save the tags, and see I'm switching back to EC2, and it's already starting and stopping the instance I just marked with the schemas, with the schedules. Switching now to the RDS console, you see that the RDS instance is also stopped.
Very good. So Ari, so maybe we can stop here.
Yep. Okay.
And so as we were discussing, so this solution is also working across accounts, and if you, sorry. So if you want to try those, so those are available in private beta. Please come and talk to us. You can find the first version of the Ops Automator on the Answers website. So now let me introduce you Michael Geisler. So Michael is the principal architect for the Vodafone video, and he will be speaking about the next step and the near future of the Vodafone television.
Thanks, Donatello. Thanks, Ari. It was a great presentation. I really like the Ops Automator. That's something we have definitely to talk about. It's really interesting. Unfortunately, we don't have it yet in our platform, but I hope and I think we will have it quite soon. So really amazing, really amazing. So maybe a few words regarding my person. So I'm leading the architects team in Wolfgang's organization. I have around 10 people around the world working with me together on creating the new way of TV in Vodafone. It's quite an amazing exercise. We built the team on a green field 2 years ago, roundabout. It's really amazing because, as you already heard, TV in the past was a really old-fashioned way on how to do things. So we came from an industry where we plugged cables. We did analog stuff. Then we came to digital. Now we are doing virtualization. So for us, this is really a paradigm shift. Now the third time within a few years, which already causes a lot of headache. I see I have to start the presentation. It's really an amazing thing we are doing at the moment, and I really love to be part of this topic. So let's talk a little bit about our future. When I talk here about the near future, well, near in Vodafone terms might be something different than you would expect for near. Round-trip times in Vodafone, or in general in opcos and telcos, and in the TV area in the past were about 5 to 10 years for new products. I think that's something different what you would talk about near. When we are talking about near now, we are trying to come down to 3 years already, which is a great improvement for us. But let's see what the future will bring. So we are still far away from a software release every 24 hours or even less, as some of you already are doing. But let's see where we will be in the future. So as you already heard, we did a lift and shift just recently, more or less. So we have put quite some of our elements into the cloud. Honestly speaking, yes, it's cloud, but somehow it was moving VMware images from on-prem to cloud. Is it really cloud? Yeah, well, cloud environment, but it's infrastructure as a service. And we only did it for parts. So we did it mainly for our content management platform and for a few services which are in fact coming from third parties who are serving as a software service partner for us. But all the main building blocks which make TV are still on-prem, so which you can see in the presentation on the bottom line. So the head end, where we are creating all the videos, where we're storing the videos and preparing, and also the delivery chain, that's all still on-prem, good old-fashioned, and nothing which is really something we can quickly shift to the cloud. We are working heavily on this, but still takes some time. So in fact, the first step was lift and shift, use infrastructure as a service, and scale down. And that's exactly where now the Ops Automator is really supporting us to reduce cost. The second step now is how the future looks like and where we are going to. Honestly speaking, I hate this road because, you know, that's the US way. It's a highway, it's straight, but in fact, we have a lot of curves, and sometimes our road is quite bumpy. So this picture is always misleading when talking to the management because they expect, wow, easygoing, straightforward, no problems at all. In fact, that's not true. So as you see, our vision for 2020, which is in 3 years from now, as I estimated, we want to do definitely much more in the cloud. So we are working in 3 main areas. So the first one is our content management systems, which we are using today. We will break them up from monolithic software into a lot of microservices, something totally new for us. We will use API gateways on top. We are heavily working on this one. We are heavily using already some services for certain parts from, as said, third-party providers who are already serving from the cloud, like, for example, CA and DRM. I will look into this topic a little bit later in the session because that's really a game changer in TV industry. We are doing recommendations, for example, already in the cloud. That's also big data analytics, a native cloud product, more or less. And we are now investigating how we can do all the video and delivery chain in the cloud. Or let's say more in a hybrid way. As you know, via Vodafone, we have a huge infrastructure, both on mobile and fixed access. And that's something we have to leverage. Would be crazy if we wouldn't use our resources there. And we have the advantage that we are close to the customers. So we have the closest data centers are more or less directly close to the antennas. So we have everything, all possibilities to really provide services which are RAN aware, so radio access network aware, for example. So that's something, an asset we really have to put into the game. So what I'm not looking into today, because that's really, as said, nothing really new for you guys, is really the CMS part, how to make software microservice and add API gateways. That's not really the interesting part. I will more concentrate on the real TV-centric stuff today. But before we do so, let me quickly sum up the main challenges we have. So for sure, as said, we have to modularize our software and create microservices. We have to make more use of cloud native. As said, infrastructure as a service is nice, but using things like Lambda, RDS, I don't know what. There are so many new services. I'm quite keen to see what's new on Wednesday. So all these services we have to leverage in the future. We have to get rid of all our on-prem systems. And believe me, we have a lot of them. You will see some quite nice ones in a few slides from now. And we have to adapt more to a concept which is a software as a service. So having more vendors who really provide a ready software for us, including all the services, including operations, all the stuff. Till now, as Wolfgang already elaborated in the beginning, TV operators always try to have everything in their own data center, have full control, own the last cable, and that's something where we dramatically have to change. And it's not only a change for us, that's also a heavy change for our operations guys because they are losing control. And that's something for them which is really, really a tough game. And we have to serve all this with same quality and reliability, but reduced cost and complexity. And as said, reliability is something in TV, 100% is not good enough. So we have data centers which are twice in the country. They are 100% reliable, full standby, hot. So we are not even dropping one frame, even if we shut down one complete data center. So the complete network is fully 100% redundant. Really amazing engineering there. But, you know, 100% hot standby means also definitely below 50% of usage of the systems. So also quite cost expensive. Okay, so besides this very few generic improvements, sure, we have to automate, something which is quite new for us. We have to modularize, we have to standardize, and we have to speed up. I hope we can achieve all the 4 of them. I said heavily working on them, but it's not only us. There are a lot of other teams and organizations inside Vodafone who also have to follow this new way of working. And it's not always the easiest to convince everybody that giving away full control is something good. Or not having the hardware in our systems, but somewhere else is something which helps to improve speed. But we, so at least Wolfgang and I, we trust that that's the only way forward for TV in the future. And let's see if we can convince the rest and the TV industry in general. Because it's not only us who are going to the vendors, everybody has to go and ask them. Otherwise, yeah, it doesn't help that much. And we are forcing them quite heavily. So today, no vendor who comes to Vodafone and wants to sell something to us who is not cloud aware, who is not approved by certain cloud vendors, they just have no chance anymore to work with us, because we see this as our future. Even if we don't apply everything today in the cloud already, we want to have the security that they will do it in the future. So I've picked two topics which I will elaborate a bit more. So the one is really the TV head end. So that's all about collecting videos, preparing videos, distributing videos. And the second one, which is also quite nice and fancy, not part of the core platform, but also important for us, is how do we manage in the future our devices. Because, you know, today we have 10 million customers on our, no, sorry, was 10 million or 1 million? 10 million customers on our TV platforms. A lot of them have set-top boxes. And sure, we, as TV operator, we always saw the set-top box as part of our platform. And we are trying to manage the set-top boxes and remote control them in the end. And in the old days, we did this, well, like always, we had our own servers, we had our own software, we had our own protocols, whatever, but in the end, very expensive and doesn't scale. So, what is the head end about? So in general, that's the platform in TV where the core happens. So that's where we collect all the videos from all the studios and all the TV channels and programs. There we encode, transcode, whatnot, prepare. We protect all the videos. Content protection is one of the core elements in the TV industry. And that's also the platform where we distribute. And Wolfgang already mentioned that we are supporting more or less every kind of distribution channel for digital live TV, which you can think of, satellite, cable, whatnot. OTT, the newest one for sure. IPTV, every kind of distribution way is somehow supported by us. And all this preparation for all these networks is happening in our head ends. Today, as I said, separate data centers. They look like IT data centers, but in the end, they are really dedicated to TV. Special operations teams, which have a long track record in TV, but unfortunately also means they mainly have not that IT experience that is today quite important. We have but also secure cages. So all the content protection in TV is managed by companies who are doing nothing else since 10, 15, 20, 30 years, with separate cages where the security stuff is inside. And one very special topic, which is a differentiator between us and normal IT, we are talking about mind-blowing data volumes. And we have processes which are also somehow mind-blowing because they are designed for more than 100% availability. So if we want to do a change, we have to go to a change board, ask. 2 weeks later, we get, okay, yeah, maybe you can think of doing the change, then go back again and whatnot. So it's quite long. So doing overnight change is definitely not happening, at least as of today. So a few words on content protection, because I was mentioning it before. As I said, it's the DNA of TV, because it's all about expensive content, where we are paying a hell lot of money to the content partners like Sony and the likes. And they have really raised the bar regarding content protection, so there's a lot of hardware involved, at least today. So we have special cages which are specially protected. That's like, data center in a data center, remotely managed. The systems are running in our data center, but we don't have any control. We are even not allowed to touch anything in there. With dedicated hardware, super secure. Some of the companies are coming from Israel. So you can think how secure the platforms are. They're really, really secure. They are certified by the content partners. So Sony, so if someone of you knows the MPAA, the Motion Picture Association of America, they are really keen on certifying such platforms and knowing how they work. And there are lots of other topics on how to secure the platform. Just to have an idea, that's how this looks like in Vodafone. And as I said, we are even not allowed to touch the servers. They are really not ours. There are a few connections left and right, and that's all we get. And inside, everything happens regarding content protection. But believe it or not, since a few months, and if somebody would have told me 5 or 6 years ago, hey, we are doing this in the cloud, I first of all would have asked him, hey, what the hell is cloud? And second, never ever. We are really doing it in the cloud now. So we have now partners who are developing the content protection systems for us, who serve the complete service from data centers, from Amazon data centers. Something really, as I said, I would have never believed. This was so, yeah, I'm just missing the right words because it's so unique, so unbelievable. But it's working, and it shows that in general, there's nothing, really nothing which can't run in the cloud if you find the right approaches and if you convince the people. And that's all about content protection for the time being, because I don't want to go into deeper. Otherwise, it's also mind-blowing. Okay, so the second headache we have. As said in the beginning, we are talking about headends, and headends mean a lot of content and a lot of data. So in general, we get our content from the studios in 3 ways. So whether we get feeds over satellite, okay, they are already, well, let's say 50 Mbits, that's okay, that's something you can handle. We get it over IP, so there's a very special kind of protocol, it's SDI, that's uncompressed raw data. And for things like VOD, so video on demand and stuff, we also get feeds as files. The problem is really the second bullet point, because one raw video in HD is about 1.5 gigabits per second. And I guess that's something you don't want to push in the cloud at the moment. Keeping in mind that you don't only have one channel, but like in this example, 200 to 300 channels, and then you're suddenly with some 100 gigabits, something you, at least today, difficult to push to the cloud in the way we are doing it today. And you also have to keep in mind we are doing this redundant, so we have this twice. So just an example, in Germany we have 2 fiber optics rings around Germany which are doing nothing else than just transferring the signals from the different studios into our headends. These fiber rings are owned by the country, they are really belonging to Vodafone Germany, and they are just for this purpose. And that's something, at least today, difficult to do in the cloud. What we are doing now, we are working on a concept where we do a kind of a pre-encoding already at the content partners, so reducing the volumes from 1.5 gigabit to maybe 50 megabit, which is still high quality, but in a size which we can already deliver. That's the way how we do it. Just, I'll skip this more or less, just an idea on what kind of special hardware we are using today. There you see some SDI routers. So this in the middle, the big box is really an amazing one. It has 1,024 inputs, 1,024 outputs, and can switch between all of them. In total, a switching capacity of 46 terabit per second. So, yeah, I think at the moment hard to virtualize. I know. Maybe I'm surprised on Wednesday, but I don't think so. And now, we shift this all to the cloud. We are trying. So at least we are trying. As I said, first step, we do a pre-compression at the content partners. We do ingest management in the cloud. We do all the transcoding. There are really a lot of new startups who have really good ideas, who really breast the DNA of microservices and cloud computing. And we can do also all the storage and PVR functionality in the cloud. The thing which I don't think we will ever do 100% cloud, at least not 100% third-party cloud, but more in a hybrid way, is the CDN. Because as said, we own the networks. Nobody can get as close to the customer as we can in our network. So there will always be CDN elements which are coming from us, which are in our network. And in the end, I hope we will have no hardware anymore in our systems, which are just used for encoding. It doesn't make sense anymore. So the second part, which is also in the headend, is then the nonlinear. That's much more trivial, because getting files, squeezing them down, yes, just still takes some time, but that's easy in comparison to the live video feeds. We are already working on a concept, or not on a concept, on a product there, where we will be able to, based on certain business rules, leverage the fact that we get EC2 instances or similar instances for very good pricing. For example, I don't know, what's the example? Nobody, Sunday night at 3 o'clock in the morning in Asia, nobody uses AWS. So we are using this time frame just to compress our videos for 10% of the price, which we would normally do. And there are quite a lot of business rules which we are applying. So is it an important video? Do we need high quality? Do we need it in time? Whatever. Okay, so the concept is that we have one basket where we get all the videos. We have an encoding manager, which in fact works on the business rules and decides then in a job scheduler which encoder to use and when. So quite easy and handy, so nothing really tricky in there. In the end, it's a workflow management based on media asset meta tags. The second part is now about the set-top box remote management. As said, we have about 10 million customers, and roughly 80% of them have set-top boxes. And as we have a lot of different distribution ways, we have to somehow manage them. Especially in cable networks, it's always important to also have a feeling of what's going on the devices and to remotely manage and control them. In the classic way, we had ACS servers, access control servers, which are standardized. So we had dozens of servers in our networks who were doing nothing else than talking with a good old SOAP-based Tier 69 protocol with the systems and getting status information, remotely setting parameters, whatnot. And now, we came to the idea, somehow sounds like IoT. I don't know why. Internet, the devices are connected, talking back and forth, we need some security. Well, maybe let's use the Amazon AWS tools. That's something we are currently working on. And we are not only using this service now or the platform to manage our set-top boxes, we also tried out to use it to manage to a certain extent the apps, which we are also providing as an OTT platform, and have created a generic notification and remote management gateway, which allows us to control both worlds. As said, using a lot of AWS services, and I'm just keen to see how this really scales in the market with 10 million devices. But that's something we will hopefully figure out quite soon in the next few months. Yeah, and that's it. I hope you enjoyed it. And maybe we do a quick summary. Wolfgang?
So since we're a little bit over the time, if I get my mic back, yes, there you go. So I think what we have learned over the past 2 years is that lift and shift works for us. You can run a serious pay TV operation out of the cloud. We have materialized our cost saving quite substantially. And it's just the beginning of a fantastic journey. As Michael outlined, there are a few nuts to crack going forward, but to close it out with our company logo, the future is exciting and we are ready, yeah? And so is Amazon. So thank you very much for having us. It was a pleasure.